Thank you all for coming. My name is Mike Hugo. I work at Entigen, where we're developing big data software for the next generation of data scientists to connect the dots between big data. And what I'd like to show to you, one of the products we've been working on and what I'd like to show to you tonight is Triplemap. So Triplemap is a search interface and a visualization interface to allow you to see connections between entities. So the first thing I'd like to show you is our basic search interface. Triplemap.com is our demo instance. It has data loaded from the life sciences domain, so we have information in here about diseases and drugs and genes from the human genome, that sort of thing. So as a researcher, I might be interested in finding out information about diseases, but not all diseases that the system knows about, not all 37,000 of them, but a particular set, a subset. For instance, all the diseases that have an onset in adolescence or young adulthood. So using our faceting capability, I can filter down the results. Now I'm looking at 111 results instead of 37,000. In addition to this, I don't want to know just information about these diseases, but I want to know what they are related to. So I can select a page here, and now I can visualize what things are related to this. So for example, there are 7 compounds that we know about, the compounds being a molecular structure that might impact that disease. And we can render the molecular structure of that entity. We can show you more information by clicking through to what we call a knowledge sheet. This has all the information that we know about this particular thing. We can render a thumbnail or a molecular structure about it, see other properties, different brand names that might apply. And we can navigate to other relationships as well. So I can see all the targets related to that disease or that compound and navigate back and forth like that. So this search interface is really cool, but what we really like to use in Triplemap is something we call a map. So I can add all of these things to a map, give the set a name, create a new map, and go into the map here. Now I have a more visual representation of what those relationships look like. So I can take this disease set and say, okay, what things are related to that? I know these 7 compounds. I can open this up and see basically the same sort of information that we saw before in the search interface, but now I'm in this visual representation of how these things are connected to each other. In addition to that, I can continue to build out a different set of things, and even though I started from this node, the system automatically detected that this new set of diseases that is related to my original set is also related to this set of compounds. So it automatically detects, as you build out your map, how different things are related. Once I've built a map like this, we have a sharing capability, so I can go in here and I can invite someone by email. I can send an email to that user. They can log into the system. We can collaborate on this map together, so we can visualize and find new entities, even if we're not in the same location. The other thing we do is there's so much new information coming into the system every day. As you build a map and as you are interested in particular entities, we have alerts. So as something new comes in, we can give you this alert or send you an email saying, hey, there's something new and interesting that might be appropriate to something you've searched for before, and allow you to visualize just the new stuff instead of everything that we have. Maps are basically like documents, so I've created this new demo map that I just showed you here, but we can save other documents and share them with other people. Here's an example map that I built up earlier, and this is a really cool feature that we like to show because it allows us to find connections that we don't necessarily know exist. So right here I have a map that demonstrates, I'm doing some research on Alzheimer's. I know that there's a gene called AD2 that is related to Alzheimer's, and I'm interested to know if there's any relationship between that gene and a molecular compound called resveratrol, which is known to be in existence in red wine. So you can see there's no line between these two things that connects them directly, but if I do an analysis and step out, I can do 2 steps. There's nothing at 2 steps. I can go in the graph, I can go even further. I can say what's out there 3 steps. And find that indeed there is a connection between these things via AD2 to AD1 to amyloidosis to resveratrol. So you can find connections that you didn't necessarily know existed, and you can keep going out even up to 5 steps. So if I go here and I try to build an analysis between these 2 things at, say, 4 steps, now I can find even more information here in this set. And if I open this guy up, you'll see that basically what we have here is a bunch of documents. I can click on one of these documents. This is entities or documents that we have scanned from the web, from PubMed, from publicly available medical journal. You can actually click out directly to see that guy and read the abstract and the source, the full text of it. So it's a mechanism to help you kind of find new relationships that you didn't necessarily know existed. But what's really cool about Triplemap is I've shown you all this life sciences stuff, but it's not restricted only to the life sciences domain. So we've built here a demo instance that has information that's publicly available. If you've ever gone to the Best Buy Open website, you know they have an API that you can download their entire product catalog or connect to a JSON API. And that's exactly what I've done here. So I've connected to the Best Buy Open. I have all of their product catalog downloaded here. I can search for different things. I can build maps that show relationships between their products. So here I can see things that are frequently purchased with this Samsung LED TV. I can see this power strip as an accessory to that TV, that sort of thing. This is possible because we have what's called the semantic data core, which allows us to pull in information from all sorts of different sources, from RDF files, from text sources, from a relational database, from an internal document site like SharePoint or Documentum, and as well as an API like the Best Buy Open. So let's say I was playing with the Best Buy data and I was interested in finding a TV. But I'm not just interested in any old TV. I'm interested in something that I can plug into SmartThings. I want a good old school CRT TV. And ladies and gentlemen, let me tell you, not only can you purchase a CRT TV from Best Buy, you can also purchase a 4-year product protection plan. So thank you very much. That's Triplemap. Come visit our website, antigen.com. Thank you very much.